I will do a little bit of talking, and then I'll do a little bit of demonstration. So, my name is Håvard. I come from Oslo, from Norway. I've been asked today like 15 times, do you not work for Autodesk? No, I don't. I work for an architectural office in Oslo called Dark Architects. I am a structural engineer by trade. I have a master's degree in structural engineering, and I graduated like 11 years ago. And 11 years ago, in 2003, there were recession times in Norway. I couldn't get a job, and I was unemployed for 6 months. And when I finally got my first job as a working engineer inside Norway in the beginning of 2004, working as an engineer in Norway then meant drawing all your reinforcement designs in AutoCAD and counting them manually inside Excel spreadsheets. So I'm sure that some of you are doing this today. How many structural engineers? Structural drafters? Contractors? No contractors. That's exciting. So basically what we did was that you would have I had an AutoCAD LT license. I got all the architectural drawings. I would extract them into my AutoCAD LT session, and then I started doing the reinforcement designs. I drew my polylines and my circles, and I had a calculator, and I calculated all the bars, and then an architect called me on my phone. I didn't have a mobile phone. So, and he said, no, this wall has to move. And then my heart just sank to the bottom of my body, because I knew that it was so much work to change the reinforcement design with this workflow. So actually, 2 or 1 year later, I met Lynn, who just stood here before me today. I met her for the first time in Barcelona in 2005, and that was also the first time ever that I saw Revit. And I remembered thinking, wow, this is cool. This will be useful for my reinforcement designs and my working with as a reinforcement designer, as a structural engineer, detailing reinforcement design. So after a couple of years working in the reseller arena and working as an engineer back in 2008, my first #1 goal for going back into engineering in 2008 or 9 was to have me and my colleagues detail reinforcement inside Revit. So this presentation and this demo that we're doing here now is sort of a collection of images and workflows, hacks, workarounds, everything that we did in order to be able to use Revit as our main detailing software for reinforcement. It's not perfect at all, but it's getting better each year, and we will talk a little bit about that. So I will introduce this session with a PowerPoint with some images of what I've done, and talk a little bit about how Revit works, and then I'll do a live demo. I'll show you basically the buttons and the sort of how to get around the different menus and commands and ribbons inside Revit. And then if we have time, if we're not too eager to go to the cocktails, perhaps we will shed some light on potential areas for innovation in the future. Okay, so there are 2 things that I think is interesting when you start talking about 3D reinforcement detailing inside any BIM software, inside Tekla or Revit or Allplan or what it's called. And that is that when you have design, to use it as a design tool, a parametric database that Revit is, you can do changes everywhere. Lynn Allen just stood here, talked about this. It's a database, so you're really dealing with information, and you're changing the information in one place, it updates all over. So this is a really positive thing compared to what I did in 2003. So you're dealing with design, but when you are modeling your rebars and anything really in 3D, there's a big potential for the construction industry to get actively involved in these models and utilizing automatic procedures for both construction and fabrication. And I will get to that part by the end of the presentation. So, what's bad in Revit? You have some stuff that's really difficult in Revit when it comes to rebars. First of all, any beam that has a tapered section, So a varying section like this will be not impossible, but sort of inefficient. Revit and the rebar tools in particular inside Revit loves everything that is rectangular. All uniform sections, all rectangles, all 90-degree stuff. Revit loves that. It's really fast, really efficient. But it's when you get into stuff like this, and especially if you have a tapered member that is also curved, because when you're modeling straight bars and stirrups, you will only be able to actually use, if you're using the automatic spacing function, you will only be able to distribute it like perpendicular to the cross section of the bar. So this is difficult. It's not impossible, but it's inefficient. And also you have stuff like this. This is a friend of mine from another engineering company in Norway who did, this was his first project he ever did, detailing rebar in Revit, and it was a nightmare because everything is curved. There's not one single 90-degree angle, and it's not sort of like the nightmare, oh, I can't do it and our company is bankrupt. It's the nightmare that keeps you awake at night and thinking about how am I going to do this, because you have to model every single bar as single elements and then copy, copy, copy. So this is difficult. It's inefficient, but it's not impossible. Stuff that gets impossible is stuff like this. When you start dealing with double curved stuff, double curved concrete walls, floors, and roofs is almost impossible, I would think. The only way to draw a wall like this inside Revit is that if you have a mass, you have a conceptual mass, and you're dealing with splines and stuff, and you stitch a wall to that double curved surface. And when you do that, when a wall or a floor is hosted by a mass inside Revit, you can't even access rebar tools in Revit. So this is like on the borderline for impossible and really inefficient. My previous company, Rambo, the company that I worked with when I did all this work with rebar, did this project. It's a cathedral in my hometown, actually, which is like way, way, way up north in Norway. And special about this project is that every single concrete wall tilts slightly inwards and is curved. So I don't know if it's double curved, but it's pretty complex to model rebars in 3D in this project. So they did everything else but rebar in 3D in this project inside Revit, but all the rebars were afterwards modeled with just lines and Excel spreadsheets like before. Now, actually, I've done this presentation before, and this list of stuff that's difficult inside Revit was longer. First time I did this was in Las Vegas in 2012. The list was really long, but it gets shortened every year. Every year a new Revit comes. So all the stuff that was difficult before, except the tapered member and the curved stuff and the double curved concrete, has been moved to the easy part. So this is getting a better presentation by the years. So the easy stuff, everything that is 90 degrees, everything that is rectangular, everything that is uniform stuff, straight, which at Rambo was like 99% of all our projects, is really easy. It's really easy to deal with the hooks and the shapes. National code shapes, no problem. Custom shapes, I did some modifications to the rebar shape families inside Revit to make them work in our company, in our region of the world. And they are really cool once you get to know the small hacks that you have to do. Small hacks that will enable you to deal with angle-driven rebar shapes that don't come out of the box with Revit, that you have to make yourself. In 2010, Revit took sort of a slight change of direction when it came to rebar detailing. I had a meeting with one of the presidents in Autodesk at AU in Las Vegas, and we were talking about this. One of the first features that they introduced after that meeting was the ability to host three-dimensional rebars inside big areas, floors and walls, stuff like this. Became insanely more efficient in, I think, Revit 12 or 13. This was huge. And this was the day when this feature was introduced, and I'll show it to you afterwards. When this was introduced, we sat down at Ramble and just said, now we do this. Now we just do it like Lynn said. So this basically, you can move the door and you can change the opening of the opening in the wall, and all the rebars will just update. So this is really have moved from difficult to efficient. Same thing you can do with path reinforcement. So area and path reinforcement in Revit was previously not, you couldn't schedule it, they couldn't hold, you couldn't see it in 3D, but now you can do both. And this is just a simple exercise for showing how path reinforcement can host three-dimensional rebars. Wire fabric mesh was introduced a couple of versions ago. They work really well, both for detailing and just rough design. And one of the biggest problems with Revit and rebar was the problem that has to do with symbolic representation, because there's no element in the building industry that has the same amount of quantity. How much is it? And that relates directly to problems of communicating. How do you communicate rebar design? Because if you have a plan drawing and you're looking at all the rebars as black, you cannot send that drawing to a contractor because it's impossible to understand. So for 10 and 20 years, people have relied on symbolic representation. You have to draw one bar. That represents a whole range of bars. And then you have some text that says, this is really a number of bars. And this was impossible in Revit previously. So the good thing with this previously was the small sections, because then you're actually looking at the real stuff, how it looks in reality. And you're not relying on symbolic representation. So sections have always been really, really efficient inside Revit when it comes to reinforcement design. And now, and also schedules, because you have a live parametric database, so every single rebar you change is automatically updated in your bending schedule. This is both good and bad. We have some issues with issues of bending schedule. You don't want your bending schedule to change unless you have control. So there's some like quality control issues with this, but I'm not going to go into detail there. But basically and this is one of the things that we had to like introduce. When you introduce new technology in a company or in a project, I always like to do it like face-to-face. So one of the things that we had to do in order to make this work was that we had to do a different bending schedule than we did before. So before, bending schedules were done in Excel. You had 10 bars on each side, and you have lots of A4 papers. This is difficult in Revit. So now I went down to the contractor. I brought the new bending schedule. It was larger. It had more bars. And I talked to him, and I sat next to him for like 30 minutes, explained why this is good, and showed him a beautiful 3D section of the rebar. And he said, okay, we'll do this. Which brings me to the 3D. So when you have modeled everything in 3D, you have a fantastic way of communicating with people. You can show them stuff like this, like a section boxed 3D view inside Revit with transparent concrete, tagged all the rebars, so for information purposes. And now also with 2015, the big enhancement of productivity inside Revit is that this is actually a plan drawing that one of my colleagues did at Rambo. Peder is his name. And up until April this year, we had to model all the rebars in 3D for scheduling purposes and the 3D. But then we had to draw detailed components inside Revit on top of the drawings afterwards for it to be understandable for people. Now, my friend Peder, he didn't know anything about AutoCAD, so he would rather do that in Revit. I'm happy he did, but now this is automatic. So I'll show you afterwards. Same thing with big sections. Everywhere, really, you have to rely on symbolic representation of a set of rebars. It's much easier now. Just a short selection of the first projects that we tried. Like Lynn said, we didn't go heads like all in on the biggest project we had. We tried the first small project. This is just a simple retaining wall outside the capital of Norway. And I modeled this, and I can say with my hand on my heart that it was pretty fast and pretty nice to do. I had to do all the symbols with detailed components afterwards, but it was pretty fast to model it. You just have to have a lot of sections and a 3D view with solid rebar. I'll show you afterwards. My friends, this is Erling's work. A lot of rectangular buildings, as you can see. This is like small power stations. Really fast to get all that rebar inside. And when you have 3D views, you can do cool stuff like, of course, with transparent concrete, you can put on some shadows, work with ambient shadows, and also like view filters for color overrides and stuff. This is pretty common for all 3D detailing software with rebar. More power stations, and then we moved on to bigger stuff. And I'll show this Revit model afterwards with all the rebar in it. This is an apartment complex inside Norway that my company did. And was the first sort of semi-big, medium apartment project that we modeled rebar in. A thing that I forgot to mention is that as a Norwegian engineer in Norway, and I think across the Nordics, I have to detail every single bar that goes into cast-in-place concrete. Every single bar. So in this project here, there are some prefab structures, but basically everything you see has to be populated by tons of rebar. And of course, everything I do in Revit, I have to make a perspective and make it beautiful. I think rebar is beautiful. When I go to job sites, I have to go and feel it and look at it, and I think it's pretty nice to see it through concrete. One day I have a dream that I will be able to see transparent concrete on a building, so you can see your rebar designs in real life. Because this is the stuff that people never see. I think this will be beautiful. Pretty hard, perhaps, to make the argument to the contractor, but I have some crazy friends also who do all the rebar design in 3D and then go to Max for rendering. I wouldn't do that, but this guy here, he photoed his head and brought it into software and then reinforced his head inside 3ds Max. You don't have to do that. So with that, I'll move to Revit, which is actually my favorite software, far more comfortable inside Revit than PowerPoint. So I'll just give you a quick, simple demo of how this works. The first thing that I always do when I deal with rebars inside Revit, I go to structure, reinforcement settings. You have 3 settings. You have the cover settings, you have the reinforcement settings, and you have the reinforcement numbers. Rebar cover settings, pretty easy. When you click on a concrete element inside Revit, it doesn't have cover settings like you can type in any kind of cover. It has a selection of covers that you can choose from. And this you can set in the rebar cover settings. I'll go fast. Reinforcement settings, you got some general settings. This first one's very important. That's actually the tick mark that makes all your area and path reinforcements post 3D rebar. So this you absolutely have to have on in case you want 3D rebar inside all that area and path reinforcement. The second one was introduced, I think, last year. You can now choose to not have rebar hooks in your rebar shape definition. I don't know if that makes sense to you. I always keep it on. The moment you I'm sorry, guys, but I think I forgot to switch to Revit. There we are. Can you see my screen? Okay, so a quick recap. I'm inside Revit. I have a beam. I go to structure, reinforcement, cover settings, and reinforcement settings. Sorry about that. Windows 8. So you want to keep these on. You can go to reinforcement rounding and do some stuff that will help you work with bending schedules inside Revit. So if you don't want to model every single bar to the nanometer, you can have it round inside your schedule and then just model it roughly. It works on bar segment lengths and total lengths. And then in 15, the new feature that was introduced with reinforcement representation. I'll show this in a different way. Now the cover setting, when you click on a bar like this, sorry, a beam, you have on all concrete elements inside Revit, you have parameters for rebar cover top, bottom, and other. Other is for a beam like this, simple stuff as the sides. So I normally model rebar by going to the reinforcement tool. I click on the concrete element first. I go reinforcement rebar, and then I choose a reinforcement shape, a rebar shape from the rebar shape browser that automatically pops up. If it doesn't, you can also use this pull-down menu here. And then I choose the rebar diameter from rebar bar, 12, 8, 14, 16 millimeters. This is all set up in your template, I hope. The rebar bar really just populates two important parameters, the material and the bar diameter. All stuff like bend diameter and hook bend diameter and all that stuff that's in your national code, that just goes into your template and you never touch that again. Due to screen resolution issues here, I cannot see all my, it's sort of hidden here, but the first thing that I do always is that let's pull up some views here. Is this possible for you to see? So I go rebar set, and then you can change it to maximum spacing with a spacing, say 150 for instance. And then when I populate my beam with rebar, you can see, let's go this way again, that it turns up in your 3D view. Actually, with a pretty irritating small feature that it will not automatically always extend to the outside of your cover setting. So sometimes I have to pull these out like this. The rebar will always snap to your cover. I don't really know, there's a tolerance, so if you pull it to the cover, it will always snap to the cover, but if you pull it like this, it will release the snap to the cover. So this is both, again, good and bad, depending on what you're doing. If you, for some kind of weird reason, needs this rebar to go just 1 millimeter from the cover, that's going to be a little bit difficult, but you can work around it just clicking on a rebar and changing the host to another host temporarily, and then just, we normally, if I miss this feature in Revit, I want to sort of explode or freeze stuff so that it doesn't change. That would be nice, I think. And one way to do that inside Revit actually is you can just group an element. So this would, normally we would do that sometimes. Just click on an element and just go create group. It will sort of freeze the element. So let's have a look. I'm going to minimize this at the a perspective view, of course. There's one thing that you need to keep in mind with rebar is that it will always default to a single pixel thickness in your 3D views. And this is odd behavior again. And you can change this by clicking on a rebar and using the parameter view visibility states inside the properties. So this is normally what I do. When I model rebar, I model lots of rebar. Model, 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 model. And then after a while, I select all the rebar and I go to view visibility states and select all 3D views and tick mark view as solid. So this is a feature I would like for Autodesk to fix, so that view as solid was defaulted for all rebars inside Revit. And when you do, you can see stuff like this. And then you can click on the rebar and change the spacing to whatever. There are like sort of limited stuff you can do in a perspective view, but if I open an orthographic view, also, you know, you have to be in fine detail level. So if I change it to medium detail level, it will force the 1 pixel thickness of the rebar. Let's change the length of this beam to 3.5 meters. It will automatically expand all that rebar. Actually, not to the, well, it expands somewhat. Let's try something different. 5 meters. It actually does, but I have a section box here. Sorry about that. 2 meters, 2.5 meters. And let's change the rebar set again to 100, really tight. stirrups there. Okay, so that works pretty well. Also, if you change the section of your rebar from 3 to 4, it will always expand. So the rebar will follow your covers. It's hosted by the element. And this is very, very nice when you're designing. But when you have issued your bending schedules, you want to sort of maintain control of what you're doing. So let's change that back, and then I go back to the section. I have a sheet here with some more views. So let's add some main rebars to this beam. I go rebar, and then instead of having the placement, sorry, the placement orientation parallel to work plane, I go parallel to cover. I change the shape to a straight shape, and the section to something bigger, 32. And then I go rebar set, single, fixed number, 3 or 4, and then you'll see that the orthogonal rebar will snap to the insides of your stirrups. This is also pretty nice. Lots of good automatic behavior here. Oh, I clicked wrong. Let's do that again. Like this, and then like this, and then I delete this one, and then I change this to, let's say, 2. Now, in case, for some kind of reason, you don't want this rebar to snap to the stirrup, you have to change the setting inside the rebar shape family. This comes from the automatic behavior connected to the style of this rebar family. So rebars inside Revit, when you model a 3D rebar like this, is done by 3 sub-elements. You can sort of see them in the family browser here. Sorry, there we are, families. You go down to structural rebar. You have the rebar bar, which is the material and bar diameter. You have hooks, which basically just have like 3 parameters. And then you have the rebar shapes. And the rebar shapes inside Revit is the only family that you can edit in the family editor mode. And you can see this if you click on any kind of rebar. You have a selection here, go edit family. If I go click edit family, what I really open then is the rebar shape family. That is like the 3rd subcomponent of the rebar. So this is where you set up your rebar shape. And this particular rebar shape is a closed stirrup, and it has all the settings. Like you can go here and say that it shouldn't be a stirrup tie, it should be a standard rebar, and then the orthogonal rebars won't snap. Lots of stuff you can do in here, lots of custom stuff you can do in here. I added some shape codes and some hook parameters for scheduling purposes. There's also a weird thing inside the rebar shape family editor. I'm just going to show this to you quickly. Is that no other family inside Revit, in any version of Revit, can have one parameter control 2 different segment lengths. So if I change this parameter here to A, for instance, now you have A here and A here, and I can change this, the length of this, to 280. A here will still be 200. Now this, in case you're not too familiar with Revit, you go, what is this? But this is like magic, Revit magic. And this actually enables you to do stuff inside Revit with the rebar shapes that you cannot do in other families, like modeling closed loops, modeling stuff that is on lines that is on top of each other. I'll show you a simple family, rebar shape family that's simpler than this. We'll skip columns. They are basically, if you want to have a happy life modeling rebars inside columns, you should install the latest version of Revit. That is like the update release 4 R2 or 5 R2. That includes some enhancements when it comes to rebar modeling. Before that, and this is like just a couple of months ago, before that you wouldn't be able to place reinforcement in any kind of element that has not view that is cutting the concrete. So typically for a column, the column goes from the floor to level 1 to level 2, and you have a level 1 view. When you're looking down, your active work plane is not actually inside the concrete. That would be a problem before, not any longer. So install that service pack. And this actually here, this is pretty interesting. This is not the 41 shape that I showed earlier. If I open this shape here, which has like 2 overlapping lines, I go edit family and again look at the parameters in this rebar shape family. You have an A parameter here and an A parameter there, and they have 2 different values. And this is good because my national code of rebars say that these should be the same. But when I change this top A here to 1 meter, I get a warning inside Revit to say you cannot have overlapping lines. So somebody thought about that and made it work. It's working well. Same thing here. If I go to plan of a pile and I go reinforcement rebar, I choose perhaps I have some kind of circular shape, placement parallel to work plane, like this. This also is almost impossible to figure out how to do. Let's see if I can find a 3D view. Like here, I go rebar set, maximum spacing. And then I go view visibility states. This is pretty irritating, view solid. But this actually adds, they don't use this in the States, so they don't know what I'm talking about, but in Norway we use this all the time for circular stuff. Overlapping stuff. Again, in the rebar shape family, you can do this without getting the warnings of overlapping lines inside a family, which is pretty good. Let me show you the, we'll skip the angle-driven stuff. This is, by the way, all my rebar content. I'm going to mention this now before I forget it. I have a web page. It's mylastname.net. And there, if you click on, go to this web page and you go workshops, Autodesk University 2014, you will see my Dynamo presentation from Las Vegas last week. And then you can download my 86-page handout of everything that has to do with reinforcement inside Revit. I wrote it down. It's almost 100 pages. It's English, sorry, Turkish version coming next year. But this is really the stuff that you got to download, print out, hand to your colleagues, because this is, there's a lot of information there that you cannot cover in like 45-minute presentation. Also, everything I did with families and all the rebar shapes and everything, it's downloadable here in humbleness, the Vasshaug rebar library. Also, actually, the PowerPoints as well. So check this out when you get back to your offices. So reason why I'm showing you this is that this rebar shape here that actually has some kind of pretty cool trigonometry in it for you to be able to change the angle of this shape. It's inside my rebar library. So let me just show you the new feature that was introduced, I think, in Revit 15. It's pretty fast. Instead of going into a section and start modeling the rebar inside this wall, you just go reinforcement, area reinforcement. You click on a major, you just go major direction, so I have the maximum like moment is vertical inside this wall, and you go finish, and it will auto-populate the entire wall with all the rebar that you need. And this is parametric because I can change exterior major spacing to 100, and it will automatically update all the rebars. So this is two things you're looking at. You're looking at the area rebar, which is just a stupid 2D element, which is hosting all the 3D rebar. And you can actually see here that you get like this rebar set over here, and you get a different rebar set here, and they're all hosted by the same area. And then you can do cool stuff like moving your doors or changing dimensions and stuff, and everything will update. Same thing with path reinforcement, and well, with that, I'm going to move back to my beam and show. So this is like groundbreaking stuff in 2012. I'm going to show groundbreaking stuff from 2015. And this is this here. So I'll actually, for this purpose, I will close my properties palette for maximum screen real estate. So basically, you had two choices before 2015. Either you show all the rebar, which I earlier explained is basically impossible because it's black, or you hide everything and draw lines on top of your 3D rebar. Now, in 15, you can do stuff like this. They added, the developers, the Autodesk, beautiful people in Autodesk, Boston and Krakow are doing this each year, making new functionality inside the Revit. You can go presentation, and these were like unavailable menus before. You can go select, and then go select none, and select this rebar I want to show, finish, and voila. So my friend Peter doesn't have to draw the detail lines any longer. It doesn't have like national code, super complex symbols for bendings and stuff, but this is pretty efficient compared to what he had to do previously. Cool thing with this is that it's view dependent. So if I go into this view here, again, I have to change the view visibility states. They can't get this right, I don't know why. So you want all the 3D views to show view as solid, and you want all the plan views to show view unobscured, that is like through the formwork. So now I can see it properly. So I click on the stirrups, and of course you're familiar with the Revit database, you select it, it's active in all the views representing this element. And then I can go preview, select, check none, and this bar in a different view. So you have the same element showing up a different bar in two different views. And this is valuable for you as a reinforcement designer for making like your drawing beautiful. 2 words on what I had to do with schedules to make bending schedules work. I don't know how you deal with lap splices in Turkey, but in Norway we have something called a running meter bar, so I can basically model a bar 150 meters long and have my schedule automatically add lap splices. I won't go into detail here now, we're too short on time, but in case you want to check that out, it's in my handout, all the calculations, it's pretty cool stuff. Basically, the short stories that are the bending schedule inside our template has a lot of calculated values. So all these parameters here you see here, they have calculated values inside them. There are calculated values actually that will just run a check and see if you're using this shape code or that shape code. And if you're using this shape code, it should add lap splices. And with that, I will move to visions of the future. For details on this, check out the handout. I will now open, a project just to have a few words about what we did and the size of stuff. So this is like five-story apartment buildings plus basement. You can see that this building here and the other part here is like a different part. It's a different Revit model really. So this was the first model that we started modeling rebar inside. So I have a 3D view here with all the rebars. This is like just pulled out of production. So it's not complete, but just to give you a view of how this works with regards to performance. So I have here, let's see, 8,553 rebar sets. So that's probably like 100,000 rebars. And this is 20% of the building. So, and check out the view performance. This is pretty fast. And also, you know, file size, it doesn't add to the file size because the Autodesk developers, you can say a lot about them, but sometimes they're just genius because they made this like a cheap 3D it's not really 3D. So every time you see a rebar inside Revit, it's not really 3D. Your screen is showing you a 3D sweep, but it's not really. And this makes it really fast, both with file size and view performance. Now the view performance, I have to say, looking at this model here, they both did improvements on view performance in 15 and 14, but also all these bars are shown with the single line pixel, no thickness. So when you turn on the thickness, this will go a little bit slower. And now, the important part. When you have modeled all these bars in 3D, what can you do? You can change the world. You can change the building design industry inside your company, inside your projects, inside your country and the world. And this is actually happening right now inside Norway. So I'm going to show you now a project that was not designed by me or my company. This is a friend of mine who is the BIM manager of the biggest construction project in Norway right now, and they're using BIM for everything. The architect is using Revit architecture, and my friend is using Tekla for reinforcement design. And what this company, Aas Jacobsen, they're called, are doing, they're modeling all rebars in cast-in-place concrete in 3D inside Tekla, and they're exporting it to OpenBIM, to IFC files, for the contractor, NCC, to work with 3D models instead of reinforcement drawings and bending schedules. So I won't lie, they still have reinforcement drawings on this project, but what the contractor is doing, and I'm not only the contractor, but the fabricators, Celso Steel Service, biggest fabricator of reinforcement in Norway, they are importing the IFC files from Tekla directly into their cloud service that is connected with the machines that are bending the bars. So all this manual labor and like room for error from physical spreadsheet into machine is being eliminated by just utilizing technology and talking to people. You have to go to them and look them in the eye and show them like that you love this stuff and you're enthusiastic, and then they will like believe you. Okay, let's do this. So basically the contractor can use like an OpenBIM IFC viewer like Solibri. This is not Autodesk software, but it's really cool because it enables the contractors to choose to have like one simple software, and then they can get like BIM or reinforcement models from any kind of vendor. For instance, Revit on one project or Tekla on the other project. And the contractors in my country really like this. So basically, everything here is in 3D, and they can go information takeoff. They can load a quantity takeoff. Go recent. I made a quantity takeoff during the Design Computation Symposium in Las Vegas last week. It looks like this, and they go take off all, and all of a sudden there's your bending schedule. So you can have the 3D view here. You have all the information from all the bars inside property sets inside an IFC viewer, and then you can just select a couple of bars and go look at this section of, so this is like the reinforcement numbers. And this IFC and Solibri is really good at this, working with the information takeoffs. So when I was a new engineer at my engineering company in 2003, cold winter months inside Norway, and I sat and I looked at reinforcement drawing and my Excel spreadsheet, and I couldn't understand anything. And I spent like a year trying to figure out all the symbols and all the stuff. To move from there to this is changing the world of design. And not only reinforcement design, but all kinds of stuff. And this is happening. This is not sales pitch, it's not demo, this is real world stuff. This is the new airport extension in Oslo. So last of all, since I have like 5 seconds left, I want to show you the coolest thing ever, and that is this. And this is the sales pitch. Although it's free open source software, this is where the world is going. So I've spoken a little bit about the geniuses at Autodesk and how they make cool new features inside Revit, but for centuries, ever since the personal computer became mainstream and inside all offices, we as designers have been slaves to what software developers have done. They have to understand what you need to do. And they sit in their desk, program their stuff, ship it inside a DVD and ship it to you, and you buy it for £100,000, and then you install it and you open it and you go like, oh no, that doesn't really work. So this is changing, and what you're looking at here is visual programming. It's a bridge for all designers to start getting actively involved in how software works and basically designing your own software. And this is the super simplest example. Basically, you can, if you want to check it out, you go to our webpage, dynamobim.org. It's an add-in for Revit. There's actually a guy next door here who did now a double presentation on Dynamo. It's pretty cool. At Autodesk University Las Vegas last week, there were like 25 presentations on Dynamo. So download it, it installs, it's free, it's open source, it installs as an add-in to your Revit session. You can find it if you go to add-ins, Dynamo. And here you can start pulling data out of Revit, working it, and pushing it back to Revit. You can start doing stuff like getting host information from, you cannot do that inside Revit. You cannot get information to the rebar of which host it is inside. So this is super simple to do something like this, with just getting the category, all rebars, what's your host, what's the name of the host, and push that as a parameter to your rebar. Simple exercise. So this is the future, people. When I come back to AUX Istanbul in 2 years, we will have some fun with this, okay? Now, thank you for your attention, and I'll join you for cocktails, I believe. Thanks.